Hello, this is Mark Zithian, FAA licensed aerospace technician, airframe, power plant, and avionics certified. The date today is July 1st, 2016. In this video lecture, we're going to cover the true power output of the two-stroke diesel piston engine. With a two-stroke diesel piston engine, the number of strokes has nothing to do with the number of cylinders, but rather the piston stroke cycle events to complete one duty cycle. On any type of two-stroke piston engine, there will always be one rotation of the crankshaft per power stroke. But just like there's some similarities between the two-stroke gasoline engine and some between the four-stroke diesel when it comes to a two-stroke diesel. And a lot of times a two-stroke diesel is used in very high performance applications like airplane racing with open propeller or drag racing. Or a lot of times you see them on the model radio controlled airplane gas engines. They'll have a little glow plug and very tiny engines, but they put out a whole lot of horsepower and RPM. So the two-stroke diesel piston engine is most suitable for high torque and high RPM applications, whereas the four-stroke diesel piston engine is most suitable for high torque, low RPM applications. So in the case of a two-stroke diesel piston engine, there's a power stroke per revolution. So very similar to the four-stroke diesel in terms of heat of air compression, only air intake will occur on the downstroke along with the power and exhaust events, 3 events. So it's kind of similar to the two-stroke gasoline piston engine, except only air will be drawn in, not air and fuel, but just air. So you got air intake, power, and exhaust events happening on the downstroke, and then you have heat of air compression, fuel delivery, and ignition on the upstroke. So the two-stroke diesel piston engine, when the piston downstroke occurs, there will be airflow that enters in the cylinder via a poppet valve, like on a four-stroke gasoline piston engine, instead of a reed valve, which doesn't really hold up to the heat and pressures of a diesel engine, right? So you'll have a cam actually that opens up the intake valve only, and then air is drawn in when the piston comes on the downstroke. And then just like with the two-stroke gasoline, there's some sort of exhaust port that will be unblocked by the piston when the piston comes down low enough to purge the fuel air charge to cause the exhaust event to happen, all on the downstroke. So you have the power, air intake, and exhaust happening on the downstroke, right? So the poppet valve will open up as the piston is coming on the downstroke, drawing in air, and right after the piston starts to move upward, of course the valve seals, and then it goes into heat of air compression, and then fuel injection, ignition, power. And so the power stroke, just like on the two-stroke gasoline piston engine, will also assist on purging the spent fuel air charge, because on the top you're going to have more of a vacuum as the piston goes down, and you're going to have more pressure on the bottom of the cylinder. The bottom of the cylinder as the piston goes to the bottom of the cylinder, like at the top of the piston as it's at the bottom of the cylinder. And so right when that exhaust port is unblocked by the piston, you're going to have maximum purge out of the exhaust, and by that time the power event has elapsed, and then the intake has occurred, and then the intake valve closes. It goes back up into heat of air compression and fuel injection and ignition, causing the power stroke, air intake, and exhaust events to happen. So that's how it works on the two-stroke diesel piston engine. And of course, you're going to get both the high RPM and high torque output on a very graduated curve between torque and RPM. So you'd have to look at what the maximum foot-pounds torque RPM is, whatever it is on the given two-stroke diesel piston engine, which you're only going to see on high-performance applications. Like with the gas turbine engine, the two-stroke diesel piston engine is close in terms of its power to weight ratio. Very important for high performance applications. A lot of you probably do racing with two-stroke diesel piston engines and can appreciate this type of a power plant. In terms of the true power output, again, you can't use the indicated horsepower. You can only use the brake horsepower. So you have to take the maximum foot-pounds torque rating at a given RPM. You take that RPM, and so you use that RPM for the number of power strokes per minute is equal to the RPM in a two-stroke piston engine. So write that down, whatever it is, and set it aside. Then take the bore and stroke and convert the bore diameter into the cross-sectional area by dividing the bore diameter in inches into 2 to get the radius, square that, and then multiply it times 3.14 or pi. You'll get the square inches surface area of the piston head. And whatever that is, write that down. And then you take the piston stroke length in inches, you divide that by 12 to get the piston stroke length in feet. Whatever that is, write that down. Now you're ready to go calculate the brake horsepower. So now we got to mathematically calculate the brake mean effective pressure in pounds per square inch exerted on the piston head during each power stroke in pounds per square inch. So all you do is take that foot-pounds torque rating, you divide it into the cubic inch displacement of the engine, which is the cc's, times 0.061. So if they give it to you in liters, 1 liter is 1,000 cc's. On a two-stroke diesel piston engine, they're probably going to give it to you in cc's. So multiply the cc's times 0.061. That will get the cubic inch displacement. Take the foot-pounds torque rating, divide it into the cubic inch displacement, and then multiply it times 75.4, 75.4, because it is a two-stroke piston engine. There's 1 rotation of the crank per power stroke, and that will result in the brake mean effective pressure in PSI exerted on the piston head, mathematically calculated. Then you take the BMEP, you multiply it times the stroke length of the piston in feet, times the piston head surface area in square inches, times the number of power strokes per minute, which is equal to the RPM where the rated torque is, and then multiply it times the number of cylinders. Let's say it's 1 cylinder. You multiply it times these 5 out, then you divide it into 33,000 foot-pounds per minute, and then you will result in the maximum brake horsepower tied to the maximum foot-pounds torque RPM. So that's how you get the true power output in the two-stroke gasoline piston engine. Now, in terms of efficiency, that is going to kind of be in a fluctuating amount of efficiency. So you have 38% brake thermal efficiency, no load, for the 4-stroke diesel piston engine, and then you go into higher RPM. So depending on what kind of fuel delivery system you have, you could have a stable thermal efficiency throughout many different RPM cycles. But bottom line is that when you start to approach the higher RPMs and you have more load on the engine, which you can handle because it's got the torque, you're probably going to see a drop in the thermal efficiency. So we would rate the overall thermal efficiency about 30% also on the two-stroke gasoline piston engine, or on the two-stroke diesel piston engine. I keep saying gasoline. You'll see about 30% brake thermal efficiency on the two-stroke diesel piston engine, like you would as the diesel 4-stroke. But it's all about high performance with the two-stroke diesel piston engine for high power to weight ratio applications. So like you have no load brake thermal efficiency of 38% with a diesel, a 4-stroke minimum at that RPM, not including the changes in compression ratio. If the engine block is very high performance for high compression and high RPM, then you can expect a sudden shift in the brake thermal efficiency and then a spike of it as it goes into constant RPM. So just to be on the safe side, you're looking also at a 30% load brake thermal efficiency in the two-stroke diesel piston engine. In terms of the amount of heat energy content in the diesel fuel, it is 19,300 BTU per pound with a fuel density of 7.1 pounds per 1 US gallon. And then every time you release 1 BTU per minute of heat output in the form of burning fuel, you're going to get 17.6 watts of mechanical power, where 746 watts of power is equal to 1 horsepower, also equal to 550 foot-pounds per second, or 33,000 foot-pounds per minute. So that's the same power dynamics of the four-stroke diesel piston engine, but the efficiency is going to hop around a little bit because of the higher RPMs, but ultimately the load RPM is going to be about the same in terms of brake thermal efficiency of the two-stroke diesel piston engine. However, there are breakthroughs in fuel delivery systems, computer controls, so now the efficiency could really go up with the growth of, or the advent of computerized EGR systems and computerized air-fuel ratio fluctuation systems and all the new electronics that are on heat of air compression systems. So just to play it safe, 30 to 35% brake thermal efficiency under a load is what you're looking at with the two-stroke diesel piston engine. And lastly, the lubrication system also is going to have some sort of a movement of the oil in a two-stroke diesel piston engine, like oil cooling, taking the oil away from the crankcase and moving it around to a radiator, or some sort of air-cooled system. Some designs will allow it to stay in, but it depends on the design. Don't be surprised on a two-stroke diesel that you have some sort of a lubrication system that is not involving the fuel. Some people, they have systems where actually the fuel will do the lubrication, just like the two-stroke gasoline. However, on larger two-stroke diesel piston engines, there will be probably some sort of a lubrication system that's external or separate from the fuel itself. So that's the power output dynamics of the two-stroke diesel piston engine, but there's a lot of innovation in these types of engines. So keep in mind the variation. Some people will argue and say that, oh, well, you know, my system is not like that. It's internal. It's fixed with lubrication. Others will say, no, I have a separate system. So be sure to look up the different design parameters of the different types of two-stroke diesel piston engines. But I give you the true power output in these videos so that if you want to mathematically calculate this to know what you need for your application, you can do so. Anyways, thanks for watching this video and have a great day.